Ospf network type is what we were focusing earlier. We are going to continue with the lab part. You see, whenever we got a frame relay in the middle, we call it as Nbma network, non-broadcast multi-access network. This frame relay network, you don't see much. Doesn't mean that it doesn't exist. We do have it in some places. In such scenarios, this 5 different type of Nbma that we learned is very useful. Otherwise, why you need this? Only the modes. You may be having some broadcast environment where DR, BDR is elected, and if you don't want that a BDR DR election, then you may go and say point to multi-point if it is multiple points. If it is 2 points, then you say point to point. So there won't be a DR BDR election. That's the only use case as of now in today's need. But with frame relay, all these 4 or 5 are very important. Doing the lab may sound like a waste of time, but I think once in a lifetime we should see these things. Do you agree with me? How many of you want to have the lab with frame relay? Okay. Let us see. But this should not make you feel difficult. This frame relay is going to be new for you. You don't know frame relay. Spending time in learning frame relay is really utter waste now. So I'm not going to teach you frame relay, but I'm going to use frame relay. So those configurations you need to focus, understand to an extent, not necessary to know in depth. You see, what we are planning to do is we are going to take 4 sites, and this is going to be a hub, and 3 spokes. We are going to have a frame relay cloud. And now we are going to have a tunnel called frame relay tunnel called PVC. Permanent virtual circuit, PVC. That's how they have named it. Like MPLS labels. Some of we don't know what is MPLS, so forget about it. I'm just talking to those who know it, just to compare. Others simply know, it's a label. Like MPLS label, for frame relay also we have a label called DLCI, Data Link Connection Identifier. It will be same like a MAC. It is used same like a MAC address. It won't be looking like a MAC address. It is used as a layer 2 address in frame relay. I'm going to show you by capturing these packets. So first what we will do is we'll bring up these 4 devices first with Ospf, and we'll have serial links here. We cannot have gig Ethernet. The reason is frame relay works only on the serial links. So when I enable frame relay, the Ospf will say the network type as non-broadcast, which is a default. And all that you learned yesterday in the previous class about non-broadcast, Ospf non-broadcast type, neighbors need to be statically configured. Just there is no dynamic discovery of neighbor. There will be a DR-BDR election. To avoid DR-BDR election, you may switch to next mode, or you need to set the priority to 0 so that they will not participate in election. This is where the use case of priority 0 comes. But nowadays you see everyone uses that. To avoid DR-BDR, simply make it as point to point. Sorry. So anyway, I erased it. The similar topology I'm going to build now, then we will discuss. Going to be the hub router, router 1, router 2, router 3 and router 4 are going to be the remote sites which are going to be connected via a frame relay. I'm going to make this as a frame relay cloud. Actually for you and me it is a router, but for the network it is going to be a frame relay device. Just for our reference, I'll make this as I'll put a cloud symbol, but that will not make it as a frame relay cloud. I'll just put the icon as cloud, but inside I'm going to make, by configuring this, I'm going to make this router to be a frame relay switch. But for all this, what we need is, see, I need serial link on all the device. So what I do, I select all the device, right click on any one of the device. Now every device is selected. Go to configure and click on slot and check whether you have a serial port. We don't have, so let us make slot 1 with serial port. 8T, T as in train, Tango, is serial. I have connected 8 serial ports on all the device. Now I just take this and I can see serial wire. I am connecting to the serial ports. Yeah, this is what we have. And I'm going to take IP address. You remember in the previous class we learned, except point-to-point NBMA, all the rest should be having same subnet on all sites. Even in the tabular column it was shown here. Look at this. Except point-to-point, all should be in same subnet. So we are going to test the first 4. Later we'll come to point-to-point, which means I need to have 10001 / let's say 24 mask, 10002, 10003, 10004. And for checking whether the routes are learned from the sites, I'm going to have some loopbacks. Same will be also used as a router ID. We had wonderful videos of frame relay in our old channel. All gone. So in our new channel, this is going to be the first frame relay video with Ospf. In those days, frame relay was very famous when I recorded frame relay videos. Now it's no more. Anyway, this is what we are going to first configure. Let us not focus on frame relay. First focus on Ospf, then we will go to frame relay. I'm not turning on the router 5. Router 5 is still sleeping. Yeah. Now allow me to use a notepad to configure the routers so that we will finish it fast. This is going to be a template for all the router. And then Ospf can be enabled in a classical way undergoing router Ospf, or you can also configure under interface. Let me use the interface level configuration. IP Ospf 1 area 0. On serial links, there is something called clock rate. So the clock rate is to say how fast the packet should pass through the serial link. For that, one side of the serial wire will be called as DTE, the other side will be called as DCE. DC and DTE. The DCE part of the wire should be on the frame relay switch. So what I'm going to say is, I'm going to say here on the edge device, clock rate 64,000. This is the speed in which the packet should be sent and received. You do it on the DCE side only. If you consider router 1 as a DCE, then you should put the clock rate here. But I told you just now that frame relay switch should be the DC. So don't set the clock rate here. When you configure on the frame relay switch, we need to configure clock rate. What is DCE and DTE? Data communication equipment, data termination equipment. See the middle device switch, it's a frame relay switch. R5 is going to be a frame relay switch. Switch is a communication device, it's not a termination device. It allows the traffic to flow between the device of same subnet. So this need to be a DCE device. So if you are practically doing this in the real world, you should use the DC end of the wire this side, DT end of the wire this side. Let me show you the cable. Fine. So these configurations go on router 1 For router 2, router 3, and router 4. Right. So we have configured Ospf on all the devices. Only the frame relay is left. Before I configure frame relay, on the frame relay switch, let's go to R1 again. R1. Meanwhile, I'll start this R5. I'm on R1. You see, right now, show IP Ospf interface serial 1/0. I'm showing the Ospf status on this interface. Look at this. It shows what? Point to point. Is it showing you non-broadcast? No. It shows the point to point type. Because according to this router, still frame relay is not configured. So you don't know that we have a frame relay environment. It simply thinks that we have a normal point-to-point, normal serial link between two routers. But it is not between two routers, between router 1 and a frame relay switch. It don't know. So when I go to the interface serial 1/0 and say encapsulation frame relay. Now, if I am going to encapsulate with frame relay, what is the default one? I'm trying to make it as frame relay now. But what is the earlier one? What makes this to be called as point-to-point is the encapsulation type. The default encapsulation is HDLC. HDLC. Let me show you that. Show IP, not IP, show interface serial 1/0. You see the encapsulation type is HDLC. On non-Cisco devices, the encapsulation type will be PPP. Point-to-point protocol. PPP. In Cisco devices on serial wire, the encapsulation type is HDLC. Now I'm going to change the encapsulation type into frame relay. Encapsulation frame relay. Boom. After I do that, I'm going to show you. So the encapsulation is frame relay. Now, if I'll take you back to this command, show IP Ospf interface serial 1/0, you can see now when the encapsulation type is frame relay, means when your network is non-broadcast. This is what non-broadcast multi-access. When you have frame relay and multiple access, it's non-broadcast. So the default network type is non-broad. It's not point-to-point. It is not point-to-point. It says non-broadcast. I told you yesterday, when your router is in Nbma, the default mode is non-broadcast. That's the very first type. There will be DR BDR election. Neighbors are not dynamically discovered. All those things we learned. Timer will be, you see, 30 and 120. See, there is a priority, which means there is going to be a DR and BDR. As of now, there is no designated router or backup designator because router 1 has not communicated so far to router 2 or 3 or 4. The frame relay cloud is still not configured. Next, I would like to show you the encapsulation now. Show interface serial 1/0. You can see earlier the encapsulation type was yes, HDLC. Now it is changed to frame relay. When you have frame relay, instead of MAC address, it will use DLC numbers, data link connection identifier number, and then local management LMI type, local management interface, LMI. And LMI type is of 3 types. One is Cisco, Q933A, and ANSI. Those things are not very important for you now. We are not focusing on frame relay. You see, Q933A, ANSI, and Cisco. This is what you are seeing. The default is Cisco. That's what you saw there. This is LMI type. And this is DTE, this side. I said this side should be DTE. Wonderful. What is now next? We got the frame relay configured and we saw the default network type on the NBMA link is non-broadcast. I'm going to configure the other 3 routers quickly with frame relay. Interface serial 1/0, frame relay, encapsulation frame relay. Yes. Now, let us get into this frame relay configuration, frame relay switch configuration. You will understand only little, and that is more than enough because it's not necessary for today's network. But I'm just trying to give the maximum. We are going to put a tunnel, frame relay tunnel between this interface and this interface, this interface and this interface, this interface, 3 tunnels. And these 3 tunnels need a unique identification. So what is that identification called as DLC? So for the tunnel that is going between R1 and R2, I'm going to give DLC number, let's say 102. For the tunnel that is going between R1 and R3, I'm going to say 103. That's the DLC number. For the tunnel that is going between R1 and R4, I'm going to say 104. On the other side, for the tunnel coming from router 2 to router 1, I'm going to say, let's say 201. This will be 301. This will be 401. Using these values, I am going to form a tunnel. Let's go. First thing is frame relay switching. This command need to be given to enable the switching of frame relay switching. The routers don't run frame relay switching engine by default. By putting this command, you are making the router to support, to act, to behave like a frame relay switch also. Which means what? It's a router. At the same time, it is also a frame relay switch. If you want to use it as a router to send BGP, EIGRP, you can do that. But we are not going to use it like that. But if you want, you can do that. This is not completely turning from a router to be a frame relay switch. It is taking additional responsibility to become a frame relay switch. That's all. Now, next is, if you see now, show frame relay route, there is nothing, no route so far, because we have not put any tunnels so far. We are going to form tunnel. Interface serial 1/0. First thing is encapsulation frame relay. Next is frame relay. Okay, one more thing, clock rate. Clock rate is 64,000. Clock rate best fitted. Okay, 64,000. I mistakenly typed something. That's why I didn't accept. Fine. See, clock rate can be anything in this range. You're setting the speed. And then it needs to be set only on the DC side. I want this to be DC side, that's why I say DC. Next, frame relay. INTF type. Interface type DC. This is also an important command. See, so far I have typed only these three commands. 1. Encapsulation frame relay. 2. Clock rate. 3. This is a DCE side of frame relay. This is the last command in this to form tunnel. Frame relay route. I'm routing for IP. Okay. Frame relay route. The input DLC number, I'm going to say 102. This is the tunnel I'm making for router 1 between router 1 and router 2. So 102. Interface serial. What is the exit interface? Serial 1/1. That is what connecting to router 2 now. What will be the DLC number on that 1/1? 201. See, this is for one-way communication from router 1 to router 2. We have written a route. Likewise, frame relay route 103. The exit interface of this is serial 1/2. What is the DLC? 301. Next, frame relay route 104. Exit interface is serial 1/3. 401. Finished. No shit. Now if you check show frame relay route, you can see frame relay but inactive status. You know why? Why it is inactive? We have just written from one direction, from hub to spokes. From spokes to hub we have not written so far. So we need to go to the spokes. Now you see, I already got the line protocol up on serial 1/0. Why? Here also frame relay, here also frame relay. So the link state is coming up, same encapsulation type. But on the other three, the link state has not come up. See, show IP interface brief. On the other side, the link state is down. Okay, anyway, the other side is administratively also down. Let me show you. Even if I make it up, the line protocol won't be up. 1/1, no shutdown. No shutdown. See, we have made the interface up, but it won't come up. It'll go down because the other side is Del C, the other side is frame relay. This side is still HDLC. We have not completely configured. This will go shortly, you see. These three will go down because this side is still HDLC. See, it is going down. The other side is frame relay we have configured. Unless I configure these three, the interface won't be up. Now you see this all gone down. So let us configure the other side. When you configure, yes, please.
Could you show me the equilibrium configuration?
On R5 we have configured only on one interface, the frame relay. That is why only that interface is successfully sending the line protocols and forming the state as up. We have not configured frame relay on the other three interface. So if you ask me to show the frame relay configuration on R5, I can show only now this interface, which is show run interface serial 1/0. Only this much. Encapsulation frame relay, clock rate, frame relay, INTF type DCE, and these things. Now I'm going to configure the similar thing on interface serial 1/1, which is connecting to router 2. 1/1, so everyone see where is 1/1? 1/1 on R5 connects to where? R2. I go here and say same commands. Encapsulation frame relay, clock rate 64,000, and then frame relay INTF type DC, and then frame relay route between 2 to 1. It's like this: frame relay route 201. For that, exit interface is serial 1/0. Del C number is 102. Now we will see route coming up. First, the interface line protocol will come up, and the frame relay route will also come up. In two directions, we have finished for router 1 and router 2. Let's check. Show frame relay route. See, this has become active. Going from 1 to 2 is possible. 2 to 1 is also possible. Next. Interface serial 1/2. Encapsulation frame relay. Clock rate 64,000. And then frame relay INTF interface. INTF means interface type DCE. Frame relay route 301. Exit interface is the same, serial 1/0, like the previous one, but the number is 103. Likewise, I need, I think I didn't say no shutdown. We say no shutdown. Interface serial 1/3. Frame encapsulation, frame relay, clock rate, frame relay route 401. The exit interface is serial 1/0 104. That's it. Now we will see all coming active. Means the PDCs are built, the tunnels are ready to carry the traffic. Show frame relay route. All are active. Both the direction. 1 to 2, 2 to 1. 1 to 3, 3 to 1. 1 to 4, 4 to 1. Totally 6. Bidirectional. For each direction 1. Alright, what is next? See, we have no IP address, nothing here. It's a frame relay switch. Now you are going to see something very nice. I'm going to type show frame relay map command. Look at this. When did I feed this? On this router, did I feed anything like this? Saying there is someone called 102. To reach that 102, you need to go to the del C 102. To reach 10.0.0.3, you need to go to 102. Did I say that any time before? No. They are dynamically discovered. Using a protocol called inverse ARP. Inverse ARP. Let me show you. Show interface serial 1/0. Using this as a source, del C number, it has learned using inverse ARP. Let me capture and show you. Let us capture using Wireshark, which is our favorite troubleshooting tool. Sorry, this won't capture. This won't capture. This is only Ethereal, only Ethernet. Frame relay it couldn't show us. Just don't have that capacity. So the protocol involved is called inverse ARP. With the help of inverse ARP, show frame relay map. Every router knows what DLCA number it should deliver the packet. See, if packet from router 1 needs to go to, if the packet from router 1 needs to go to router 2, it should go where? To 102, not to 103 or 104. That's what you see here. The packet to be delivered to 103 if you want to go to router 3, 10.0.0.3. This discovery is dynamically done using inverse ARP. Fine. But OSPF will not. Even though router 1 can ping, even the router 1 can ping router 2, router 3, router 4 through frame relay. We don't see neighbor, show IP OSPF neighbor, no neighbor. But OSPF is running on every router. Let us see, show IP OSPF interface brief. It runs on all the interfaces. And everyone is claiming themselves as DR. Let me show you on the other routers. Router 2, show IP OSPF interface brief. Router 2 also says I am running OSPF, I am a DR. Router 3 will also say the same. I am running OSPF, I am a DR. Everyone is saying I am a DR. Show IP, not here. Router 4. All are running OSPF, but they are not forming any neighbor. Show IP OSPF name. Why they will not form neighbor? Because this is non-broadcast. Show interface serial show IP OSPF 1/0. You see, it's a non-broadcast type. The timers are 30 and 120. The neighbors will not be dynamically discovered. We learned it. Now we are going to do what? Configure the neighbors manually. I'm going to router 1. Router OSPF 1 neighbor. Should give the IP address, not the router ID of R2. Only IP address is reachable, no? So give, what is the IP address of router 2? 10.0.0.2. Neighbor 10.0.0.3. Neighbor 10.0.0.4. Likewise. We'll go to router 2 and say router OSPF 1 neighbor 10.0.0.1. Like this we have to configure the neighbor manually. I'll go to router 3. You have to configure on either side. If you configure on one side itself, it will come, but it's not good. Have to do it on all sides. Router OSPF 1 neighbor. Done. Now only the neighborship will come. Let's go and verify now from R1. Show IP OSPF neighbor. You can see 3 neighbors. Show IP route OSPF. But I'm learning only 444. What happened to 3333? Let me check whether I configured router 3. Router 3 show IP OSPF interface brief. I do have it. Maybe we need to wait. Oh, you know why? I know why. It is because of DER BDR. Not everyone is going to send update to everyone. So there is one router here. Let's see who is that. Show IP OSPF neighbor. This will show the DR is R4. That's the reason. R1 and R4 has got full relationship, not with R2 and R3. That's why you don't have the routes of R2 and R3. This non-broadcast OSPF this non-broadcast type will elect a DR and BDR. Right now BDR is router 1. DR is router 4. See, if the hub goes down, there is no need of this. There is no use of the hub router. So this is only recommended. This is only recommended if you have full mesh. This non-broadcast mode. Do we have full mesh? No. So what we can do? We can switch to point to multi-point, where there won't be DR BDR. Let's switch to point to multi-point. Very simple. Go under interface serial 1/0. But neighbors need not to be configured manually. I'll remove the neighbor. Router Ospf 1. I'll remove those neighbors. I removed all the neighbors. Likewise, I'll also remove. Hope you recall what we learned yesterday. We saw for next second one, point to multi-point, the neighbors are dynamically discovered and there is no DR BDR election. Because it's hub and spoke, neighbors removed. So what is that needed? Go under all the routers interface and change the network type. IP Ospf network type point to multi-point. Here neighbors are dynamically discovered. You can see neighbor coming up automatically. See, it has come up. Automatically it will come up. The neighbor which was down, because I removed the neighbor shape, will come up as soon as I say yep. Even on R1 I should say that. Let us verify now. Show IP Ospf interface serial 1/0. You will find the network type is no more non-broadcast. It is what? Point to point. In point to point, the priority will be 0. There won't be any DR BDR. That's why there is no mention about DR or BDR. Alright. Now let's verify. Show IP Ospf neighbor. You got, see, 4 neighbors but no DR BDR. The priorities are 0. Show IP route Ospf. You see all the loopbacks and all the networks. If you want to ping, you can ping 2.2.2.2 with a source of 101. You can ping all the branch offices. See, now we have seen 2 types out of 5. What we have seen is what the industry standard. Every vendor knows this. The other 3 that we are going to see is Cisco standard. So let's see the third one. As soon as I configure the third one, what will happen? The neighbor will go down. Why? We learned that in the third one, which is called as point to multi-point non-broadcast, the neighbors are statically configured. At the same time, no DR BDR. Let's see. Interface serial 1/0. Earlier I configured only point to multi-point. Now I am going to add non-broadcast keyword. This is the third one. The neighbor will go down now, because neighbor need to be manually configured. Then what is the difference between the first one and this one? In the first one, neighbors are manually configured, but there will be a DR BDR election. In this, neighbors are manually configured, no DR BDR election. Sorry. Now the neighbors are all gone down. Show IP OSP of neighbor, no neighbors. So we have to configure the neighbor manually. I'm going to use the notepad to configure it. Enable config t router OSPF1 neighbor 10.0.0.2 neighbor 10.0.0.3 neighbor 10.0.0.4. This is on router 1. So now if you see show IP OSP of neighbor, no neighbors, it is dying actually. The timer, you see, it's dying. What is the timer? What is the dead timer? 3 minutes. 120. It's a WAN. Show IP OSP of interface serial 1/0. You see the timer here. You see the timer is 120. That's why it is still not expired. The neighbors are not thrown out. Clear IP OSPF neighbor. Show IP OSP of neighbor. See, it's expiring one after the other. Dead. All are dead. Now let's put our configuration. Likewise on the other router I need to make R1 as a neighbor. That's it. Now you will see neighbors with no DRBDR. Show IP OSPF neighbor. Neighbors but no DRBDR. All the routes are seen. Right, so we have seen 3 Nbma types so far. Non-broadcast, point to multipoint, and point to multipoint non-broadcast. And we got another 2, which is broadcast. Another one is point to point. For broadcast also we can have the same topology. Why? We learned that same subnet is needed for broadcast. For broadcast also we can have same subnet. This is what left and this is what left. But for this we need to have different topology, different subnets, which will take some time. We'll do it now. But first of all we have to see this one. Now what is the similarity between this? Even though it is through the frame relay, the timer is going to be 10 and 40. For these 3 which we have seen now, it is 30 and 120. Yep. So the last 2 is broadcast and point to point. What is the connection between broadcast and Nbma? There is no connection. Broadcast is opposite of non-broadcast. So why are we then talking about broadcast here? Even though it is an Nbma non-broadcast multi-access, you want OSPF to behave as it works, as it behaves in a broadcast environment. That's what your expectation is. How in broadcast environment it behaves? When you simply connect routers, via a normal layer 2 switch, how it behaves? The neighbors are dynamically discovered. There will be DR BDR. Along with that, timers. Timers will be 10 and 40. If you want advantage of all this, then you may think about configuring the network type as broadcast. So I'm going to show you that now. Right now what we have is point to multi-point non-broadcast. What we have is point to multi-point non-broadcast. The neighbors are statically configured, manually configured. So I'll go and remove first. See, show run section Ospf. You see, the neighbors are statically configured. I'm going to remove those neighbors. I'm going to remove this neighbor on all routers. Done. So we will not find neighbors anymore. Show IP Ospf neighbor. Gone. Show IP route Ospf, nothing. Now you see, is it a non-broadcast environment? Yes, but I'm going to say router, not router. Interface serial 1/0 IP Ospf network type broadcast. I'm saying Ospf, just assume and bring me a broadcast feeling, broadcast experience. I need to put this on all the routers, so I'll copy this. Router 2, router 3. The neighbors will come up immediately because the broadcast will discover the neighbor dynamically, and there will be a DR BDR, and the timer will be 10 and 40. That's what you're going to see now. What I did, I should have not pasted in router 5. Should have pasted in router 4. Router 5, how it will come? Router 5 is a frame relay switch. Okay, so what I'm expecting now is R1 to have neighbor. Show IP Ospf neighbor. You see, it has got 3 neighbors, and you see there is a DR BDR election. R3 is seen as a BDR. R1 is a DR. R1 is a DR. R3 is seen as a because R1 is a DR, everyone is forming full neighborship, full adjacency. Go to R2 and check. You will not have all neighbors with full adjacency. Only one neighbor. What are the other things? Timer. You see, in a non-broadcast environment, you want all this advantage, then you can go for this network type called broadcast. Even though it is a non-broadcast environment, it is giving you result as if you have a broadcast environment. I used to wonder whenever I am in Dubai, I used to wonder, like, you get everything. Something you don't get in India, you will get it there. That's a desert. It's a desert which provides everything. The best Talapakati biryani I had is in Dubai. Even though Talapakati is from India, Tamil Nadu, the Talapakati restaurant in Tamil Nadu, they are not really good quality restaurants. In Dubai, there is a place called Bardubai. In Bardubai, you have Talapakati restaurant. Wow. Wonderful mutton chops.